Joule per second meter square, CGS unit is Dian per second centimeter square. And intensity is related to the number of photons as follows. It is intensity per energy per unit time per unit area. Suppose there are n photons, so energy is nh nu by Ta. So if all these terms are constant, then intensity is proportional to the number of photons. So we can say that graph between intensity and number of photons will be straight line, obviously for a corresponding constant frequency. Next is, so hence we can say that for a given frequency, number of photons is proportional to intensity is proportional to number of photons striking the surface per unit area per unit time. Now there are different cases. Suppose there is a point source of light, so intensity is proportional to 1 by area. So that point source will be enclosing a sphere, and area will be proportional to 1 by r square. So intensity is proportional to 1 by r square. And if we compare intensity from two sources, it will be equal to d2 square by d1 square. That is how we can solve this out. And intensity is proportional to number of photons. So from here you can calculate the ratio of number of photons itself. Then for a line source, we have intensity as proportional to 1 by r for a line source. So that is inverse relation, and its graph is a rectangular hyperbola. Now there are certain things regarding photoelectric effect. It was observed by the sequence is observation, then experiment, then result, then problem, then solution, then analysis. We shall continue discussing that in a few seconds. Now there is another question that a point source is emitting photons of wavelength lambda. Photons are received by a small area at a distance a, itna. The ratio of wavelength of the photons, ratio of frequencies of photons. So as we have done earlier, that intensity is proportional to 1 by d square, and intensity is proportional to frequency, that is inversely proportional to wavelength. So in this way you can find ratio of wavelength, then ratio of frequencies, then ratio of single photon, then ratio of intensity of photon in the two cases, the number of photons in two cases. We can solve this using the earlier question that I discussed. Now let's begin working on the photoelectric effect. So the sequence will be observation, then experiment, then result, problem, solution, and then analysis. We shall proceed in that way. So before that, let's study the spectrum of electromagnetic waves. It's radio, micro, infra, light ray, UV ray, X ray, and gamma ray. And if we